Deep within the arid coastal deserts of Peru, a silence hangs over the dunes. This landscape, scorched by the sun and whipped by the wind, hides a secret that defies the very laws of nature as we understand them today. You are standing in the Playa Media Luna, a place that feels as far removed from the ocean's abundance as you can possibly get. But a brush sweeps away millions of years of sand, revealing a predator's tooth. It is ancient, massive, and jagged, a weapon belonging to a creature that should not be here. At first glance, the density of the bone suggests a whale, a leviathan of the deep stranded miles from the nearest shore. But as the excavation continues, the paradox deepens. The spine uncurls from the rock, vertebra by vertebra, looking perfectly aquatic. It tells the story of a swimmer, a beast built for the currents, until the team reaches the hips. In a modern whale, the hips are nothing more than tiny, floating slivers of bone, useless remnants of a forgotten past. But here, the hips are robust. They are attached firmly to the spine, and extending from them are not fins, but legs. Long, weight-bearing legs. This is not a dinosaur. It is something far more confusing. You are looking at a biological impossibility. A whale that could walk. Science has named it Peregocetus, pacificus, the traveling whale that reached the Pacific end. It is the tangible proof of one of evolution's most daring experiments to understand this anomaly. You have to rewind the clock. You have to go back past the ice ages, past the dawn of humanity, deep into the Eocene epoch, 50 million years ago. The Earth was a hothouse then. There were no polar ice caps to cool the planet. Sea levels were high, and the continents of South America and Africa were locked in a slow, drifting divorce. Evolution began this specific journey not in the ocean, but on land. The ancestors of this creature were wolf-sized scavengers in Pakistan, four-legged animals that had never tasted salt water. But the shores were crowded and competitive, while the water was an untapped all-you-can-eat buffet. Driven by hunger, they began to wade. Generation by generation, they ventured deeper, their bodies slowly twisting to suit the current dot. The discovery in Peru is the smoking gun of this transition. It represents the moment when these creatures were no longer land animals that liked to swim, but sea monsters that could still walk. But here is the mystery that kept paleontologists up at night. The ancestors lived in Asia. This fossil was found in South America. How did a dog-paddling walker cross the entire Atlantic Ocean? Geology holds the answer. 50 million years ago, the Atlantic was only half as wide as it is today. Driven by currents and following food, these walking whales embarked on an epic transoceanic migration. They were the Vikings of the Eocene, resting on islands that have long since sunken beneath the waves. Until finally, exhausted and battered, the first amphibious whale dragged itself onto the mudflats of Peru. A new world was conquered. Picture the creature that pulled itself onto that ancient beach. It stood 4 meters long, dwarfing a human. It was not a clumsy, dragging seal. It was a formidable beast. If you zoom in on the toes of the fossil, you find a detail that feels like a prank. Tiny hooves. This creature is an ungulate, a distant cousin to horses and hippos, carrying the genetic baggage of its terrestrial past on the tips of its webbed feet. On land, it would have moved with an awkward, undulating gallop, an otter the size of a crocodile, its heavy tail counterbalancing its long snout. It wasn't graceful, but it was functional. It was a walker, but the water was calling. When it slid from the mud into the river, the clumsiness vanished. The gravity lifted. The creature transformed from a stumbling beast into a torpedo. The tail vertebrae are thick and robust, anchored with massive muscle attachments. This was the engine. Unlike fish that move side to side, this mammal pumped its body up and down, galloping through the water. This spinal flexibility is a trait that defines all whales today. But unlike modern whales, this ancient walker had a flexible neck. It could turn its head to look at you, scanning the environment with large, high-set eyes that watched above the water like a crocodile while hunting below. The teeth tell us it was a pure carnivore. These are not the baleen plates of a gentle filter feeder. They are scissor-like shears designed for slicing. It hunted large fish and perhaps even unsuspecting birds along the coast. But it was not the only monster in the water. The Eocene oceans were a place of high risk. Massive sharks and prehistoric crocodilians patrolled the shallows. This explains the legs. Land wasn't just for travel. It was a safe house. When the sharks came out to feed, or when the mothers needed to give birth, the whale could simply walk away. They nursed their pups on the beach, keeping the next generation safe from the deep. Straddling the line between two hostile worlds. We know these details not just from the shape of the bones, but from the chemistry locked inside them. Modern paleontology is a digital forensic operation. By drilling microscopic samples of tooth enamel, scientists can analyze oxygen isotopes. The chemical signature proves that this animal ingested seawater, confirming its life in the ocean. But cross-sections of the bones reveal something else. They are solid. There is no marrow cavity. This condition, known as osteosclerosis, acted as natural scuba weights. These heavy bones provided ballast, helping the buoyant animals sink and glide effortlessly beneath the waves without expending energy to stay submerged. Every inch of this skeleton is a compromise, a chaotic mix of terrestrial runner and aquatic swimmer. But evolution is a tinkerer, and you can see the changes happening in real time on the fossil. The nostrils were beginning their long migration from the tip of the snout toward the top of the head, the first step toward the iconic blowhole. The ear bones were becoming dense and shell-like, adapted to pick up sound waves traveling through fluid rather than air. It is a snapshot of a species in flux, caught in the middle of the greatest transformation in vertebrate history. It sits right in the center of the family tree, the Rosetta Stone that translates the impossible language of how a hoof became a fin. However, being a generalist comes with a cost. As the eons passed, the world began to change. The oceans cooled and the currents shifted. The call of the deep grew stronger. Being able to walk was a survival trick, but it was also an anchor. To truly conquer the ocean, they had to let go of the land. The legs that had carried them across continents slowly shrank. The webbed feet that had slapped against the mud of Peru dissolved into sleek, steering fins. The tail grew a massive fluke, becoming the sole source of propulsion. The land became less of a home and more of a memory, until finally, it was a place they could no longer visit. The extinction of the walking whale was not a failure. It was a graduation. Evolution moved on. The legs vanished entirely, giving rise to the fully aquatic giants we know today. Enter the Basilosaurus, the terrifying serpent whale, and eventually the modern leviathans. Because of this awkward walking experiment, we now share our planet with the blue whale, the largest animal to ever exist. Every time a modern whale breaches the surface, galloping vertically through the water, it is using the same spinal motion that its ancestor used to run across the plains of Pakistan. The legacy of the walker is written in the movement of every giant that patrols our oceans. For every fossil we find, millions turn to dust. This single skeleton in the Peruvian desert is a lucky lottery ticket, a rare snapshot preserved against the odds of time, wind, and erosion. It reminds us that evolution is not a straight line. It is messy, creative, and brave. Life will always find a way to move where the resources are, even if it means completely redesigning the body plan. It forces us to look at the world differently. When you look a whale in the eye through the glass of an aquarium, you aren't looking at a fish. You are looking at a cousin who took a different path 50 million years ago. A mammal that once stood on a beach and decided to return to the water. The desert where this bones lay is still vast, and the rock is deep. We have only scratched the surface of the Pisco Basin. Drones equipped with ground-penetrating radar are now mapping the dunes, hunting for the next anomaly. We are left to wonder what other secrets are buried in the sand. What other impossible creatures are waiting to walk out of the stone and rewrite history? The story of the whale that walked is complete, but the story of discovery is only just beginning.